Example 5, perform each operation. F plus g of 1. That means f of 1 plus g of 1. Not supposed to be hard, but students struggle because their eyes go crossed. If you're looking at f of 1, that just says x is 1. So f of 1 is this 1 right here. G of 1 is this number 6 right here. All that says to do is 1 plus 6 is 7. G times f of negative 1. So g of negative 1 times f of negative 1. You look at x equals negative 1, and g of negative 1 is 2, and f of negative 1 is negative 3. I'm going to get negative 6. Okay, give me those all day long. I'll do those all day long, right? That'll be quick. Composition of functions is when you plug one function into another. So look at the notation with the little circle. That does not mean multiplication. That means composition. That means you're plugging one into the other. Specifically, it's like it works backwards, okay? It's like you take x and you put it into the g function, and then whatever you get for that, you put it into the f function. It's kind of going backwards. Okay, so part A says f of g of 1. Work it backwards. You put 1 into the g function. So you'd have 5 times 1 plus 4. That's 5 plus 4, that's 9. Okay? So g of 1 is 9. And now we're going to have to take f of that result. F of 9. So I'm going to plug 9 into the f function. I would have 2 times 9 plus 6. That's 18 plus 6. It's 24. Again, you read that symbol as of, f of g of 1. Next one, f of g of x. F of g of x. So work backwards. The x goes into the g function. Well, that's easy because if you plug x into the g function, you just get 5x plus 4. That's it. So you're going to take that result, 5x plus 4, and plug it into the f function. So this is where it gets a little bit confusing, I suppose. The f function says 2 times something plus 6. And we're plugging in 5x plus 4. You're plugging 5x plus 4 into the f function and just do what it says to do. It looks like distributive property, so I'm going to distribute that 2, and I get 10x plus 8 plus the 6 would give me 10x plus 14. Number 7, you've got two functions, find the composition and give the domain. So it says f of g of x. That's what this says right there. Well, g of x is just 2x plus 5. So we've got to plug that into the f function. Okay, so plug it into the f function. That's the square root of 4 times something plus 28. And we're plugging in 2x plus 5. So we can distribute right there and get 8x plus 20 plus the 28 is going to give me the square root of 8x plus 48. Now, you could probably clean that up and simplify. You could take out a 4. I'm not really worried about simplifying the radical right now, so I'm just going to leave it alone right there. Square root of 8x plus 48. But we want to find the domain. Okay, and for the domain, again, you have to look for problems. okay? You have to look for problems. And so looking for problems, I don't see a fraction, so I'm not going to have a denominator of 0. I don't need to worry about that. But I do have to worry about this being greater than or equal 0. You have to have, whatever's under your square root has to be greater than or equal 0. So for the domain, we're going to say, well, 8x plus 48 must be greater than or equal 0. So subtract the 48 over. That's going to be 8x is greater than or equal negative 48. And divide by 8. And that's going to give me x is greater than or equal negative 6. You don't have to draw a number line, but sometimes I think it helps. If you had a number line, you'd say filled in circle on negative 6, arrow to the right. That tells me exactly what my interval will be. My domain is going to go from, bracket negative 6 to infinity. Okay, last one. You got two functions, find the composition, give the domain. So f of g of x. F of g of x. Well, g of x is just this 2x, so we want f of 2x. The f function says 5 over something plus 10. So literally, I mean, I've written a lot, but all I'm doing is plugging one function into the other. Plug the 2x into the other function. You've got 5 over 2x plus 10. So, clean up a little bit. You got 5 over 2x plus 10. Can't reduce that, so just leave it alone. There it is. As for the domain, are we going to have a problem with a 0 on the bottom of a fraction? Yes. Okay. So we have to worry about that equaling 0. 2x plus 10 cannot equal 0. Otherwise, you get a 0 on the bottom of your fraction. Subtract the 10 over, so 2x should not equal negative 10. Divide by 2, so x should not equal negative 5. If you look at a number line, it's basically everything except negative 5. If you look at it like that, I think it's obvious that there are two parts, okay? There are two pieces of the number line. There should be two pieces of your domain, okay? There are two parts of this. The domain would be from negative infinity to negative 5. Parentheses means it's not equal to. Unioned with negative 5 to infinity.